Okay, so in the previous tutorial we showed you how to create a dataset. So we're going to open up that dataset again, and you'll see here it's empty. We have a dataset, we put some information into the name and description, but we don't have any reactions. If we want to add reactions to that dataset, there's 3 ways of doing it. We can create a new reaction from scratch. We can load in a file, much like what we did with the dataset, except this file would contain just a single reaction in it. And we can also use the enumeration tool to take a template file and some reaction data in a spreadsheet and enumerate that template over the spreadsheet. But for today, we'll just focus on building a reaction from scratch. So here we go. We've opened up a new reaction and it's empty. It's blank. First thing we can do here, it's optional, so it's given it a hexadecimal ID, but you might want to, give it your own ID here. So maybe I might say this is my, if I'm working in the lab, that's my first experiment in project 1, I might give it a lab notebook ID like that. Okay, so I've added a reference ID that makes sense to my work. Now we need to go through the various tabs and put information in. I'm not going to show you all of them here. I'm going to show you sort of the fields that are most common to use. And you'll see here some of these asterisks. These mean that there are mandatory fields here. So there's some information that must be included. We see here as well, we have a bunch of errors showing up. Just 2 of them here. So, we can't have a reaction without at least 1 reaction input. And we also can't have a reaction without at least 1 recorded product. So we'll fill in that information first. Okay, so on the inputs tab here, this is looking at every chemical input that's going into the solution. So let's start off, we'll add an input here. And we're going to call this one, this here name is just a reference name. It doesn't matter too much. You can give it we'll call it the aryl halide core solution. This reaction I'm going to document here is a example microscale reaction from a high throughput experiment where someone's done thousands of little micro vials set up by a robot. So here we go. So we give the input a name, and then we need to add some components to it. So this here is a solution. We're adding a solution into the reaction, so that solution will contain normally some kind of reactant or reagent and a solvent. So let's add our first component. It takes us to the component view, and the first thing we're going to add here is our reactant. So we'll specify the role as reactant, and let's say this is the limiting reactant here, so we'll change that Boolean field there. We need to add some kind of identifier or drawing to basically say what the chemical is. So one of the ways we can do that is we can use a smile string. So I've copied this from elsewhere. I can come in here and I can go, give me a new identifier, make it a smiles, paste that in there, save, and it's reaction update. If I close that now, we'll see here this is then added in that reaction identifier, and underneath the hood it is then used RDKit to draw that for us. So there's a bunch of identifiers in here you can use. Smiles, Inchy is another good one. It's another structural identifier. You can use various other IDs as well. We usually, we prefer if you can use some kind of structural identifier like a smiles or an Inchy, because that, allows us to draw the chemical structure. So let's just cancel that one. Okay, so that's our first component. Oh yes, we need to give it an amount as well. So ORD, you need to give an amount. So in this case, our amount is 100 nanomoles. So 100, and we select from here, nanomoles there. Okay, and we can save that. There is extra information down here you can add. We'll probably cover some of that in a more advanced tutorial. And let's go back up to the input. So we see here then, this input we're creating the solution. we have the reactant. So let's add the solvent. So we go add component. We're going to add a solvent, and this time let's use the lookup field. So we go lookup, and I want to look up DMSO, dimethyl sulfoxide. Go save. Oh, it's not found that. Okay. Okay, let's be more specific. So what that's doing is it's taking the text you give it there, and it's looking it up on PubChem and some other databases, and then pulling the information from there. And so it's pulled out a SMILE string for dimethyl sulfoxide, and then uses that to draw our structure. So we need to give it an amount again, remember. So this time it's 250 nanoliters. There we go. When you do a volume, we're also asked to say whether that volume includes the solutes or not. This comes down to the way we make up stock solutions. So in this case, if we're adding a solution of this reactant in 250 nanoliters of the solvent, which normally often will say true here. Okay, and then we can save, and we'll close that. This is then our solution. We scroll down. This is the inputs page here, input sidebar. Scroll down, we get various other bits of information about how that solution is added. And we do highly recommend you use these fields. Order here would say this is the order we're adding things. So if this is the first solution we add, that's number 1, and then the next solution we add will be number 2. And you can add device, pipettes, pumps, things like that. So let's leave that for now. Let's add another input. So this time we're going to add our boronic ester. Boronic acid ester solution like this. And to add the component here, we're going to show you how to draw it. So if I go add component, we can use a catcher window to draw our component. So we do this, and it's a bit like ChemDraw. You just go and place your atoms on here. So we're doing the metaboronate like that, and then I'll come back to there, to there, to there. It goes to there, like that, and we need to place our heteroatoms. So there, we need a boron. There, and we need to get some oxygens. Oxygen, and I believe that is what we're after. So that's our boronate, and then we can just go save. And so that's added in a mole block identifier. So then drawn that, and I can then go say that is a reactant, and we need to give it a quantity again. This time it's 150 nanomoles. The last one was 100 nanomoles, so this is not the limiting reactant. There. So I can save that. Let's go up to the previous level. This is a solution. Let's add the solvent. Actually, let's show you a different way to do that. Cancel. Let's save the input. Let's jump back to our aryl halide solution. Open up our DMSO, and one thing we can do with the new editor is if I have part of a reaction open like this and I want to reuse that, I can copy that chunk. And now if I go back, I go into the new input, add component, I can go paste chunk, and it's going to replace information on this page. And here we go. So we've added DMSO, the same volume, and yeah, the same details there. So that's a handy feature. Maybe a bit overkill in a situation where you can look up dimethyl sulfoxide, but elsewhere in the schema you can save a lot of time using that. So let's save that. And then the final one I'm going to show you then is how to paste in complex structures from outside. So we have our catalyst solution as our final, well, another input in this one here. So we're going to add a component, and separately I have drawn in, this is in ChemDoodle. You can use any chemical drawer. Draw out your structure. Now sometimes this is necessary for complex organometallics. Smile strings don't always handle them so well, so do be careful with smile strings on organometallics. Make sure you're getting the structure you think you're getting. So if you're unsure, draw them out, and we can copy that. And I'll go edit, edits, copy as. I want to copy this as an MDL mol file. So now when I go back into here, I can open up my mol block, my catch window, and it's Control V, paste that in, and if you need to make edits to it, save. So that is another way of adding in your chemicals. And of course, here we go, we say it's a catalyst, and we've got 10 nanomoles of catalyst. There we go. This is added as a solution with some DMSO. That, save. Solvent, 250 nanoliters. True. And so we've added here, we can see the first of the 3 solutions we've added there. We get a summary view here with all the drawn out all the structures, the roles, the quantities, and I'm going to off the video add the rest of the information here. But for now, you can see the range of different ways that you can add your chemicals in when creating a reaction. So on to outcomes. So for outcomes then, it's a similar sort of view here, except instead of inputs, we have an outcome. So an outcome is a time point. So our time point here is 22 hours. So the reaction's been run for 22 hours, and then a sample is taken, a workup is done. You basically get in your measurements at that point there. So we create an outcome. I can save that for now. So we see here, this outcome here. I could create another outcome. I could say, if I check this reaction at 5 hours as well, I can save that in there, and you can see we have then the multiple outcomes here. But let's delete that one, we don't need. We're going to add some products and some measurements to our outcome. So often the first thing I'll start with is the analysis. So what type of analysis have you done? So let's call this is a UPLC MS. The type, pick from the types in here, use a custom if there's not a suitable one, and then you can give it a CHMO ontology ID if you want, but let's leave the rest. So details here, you could put in method details there. Let's leave that for now, close that. Let's add a product. Okay, so like we did for the chemical inputs, we can take a smiles string, copy, no, let's do this, add identifier, smiles, value, save. So that is our product. And that is our desired product as well. So we've created the product. And if we want to create a measurement associated with it, so we've measured a yield, we come down here and we go plus measurement. We need to pick what type it is, so it's a yield, it's based on, and you can only pick from the analysis types you've already added, and then you give it a value. So in this case, let's say it is 58% percentage there, and you have a few options here for saying whether it's internal standards, whether it's normalized. Let's leave those for now. So save that, close it. We can close down the product. No, let's save that, close. Okay, we can also add a second product here. So let's say we're also measuring leftover reactant. So we can load up our reactant. We have to add it in again, but here I've got a smile string. Remember, you can also do drawing them out, looking them up if it's relevant. So let's give it a smile string, save, close, and add a measurement. This is a yield based on UPL CMS, and there's 14%. Let's say there's 14% left. Save, close, save, close, close. So here we go. We have here then our summary. We have an outcome, time 22 hours. We have the products listed down here under the outcome. So our product, our reactant, any measurements you've recorded listed there, and then any analysis types which have been made are listed along here. So that is our inputs, our outcomes, and then the final mandatory section is provenance. And we just need to say, at the very least, who did the experimenter, who recorded the reaction. So there's two groups of fields here. There's the experimenter. Now I'm copying this data from a paper, so I would say I'm not the experimenter here, but if you did the reaction, put your name down here. Take credit for it. But in this case, I am the contributor. I am creating the reaction record. So I just need to make sure there's some minimal details in here. So we have a time stamp, and we need at least one of an email address, an ORCID, or a name. So you need one piece of identifying information here so that we can attribute the reaction to you. But that then it's passing validation there. So this is a valid reaction. There is far more information we can put in there, and I will show in the next video some more details that you should really be adding. But for now, this is a minimal valid reaction which could go into the Open Reaction database.